All right, so let's get started. So have you all typed in this URL already? Okay, so you have this GitHub page open, and there's a button here that says Open in Colab, and then it will look like this. So before I get started, I'm Wasir. Thanks for coming. I'm the Research Data Librarian. I am part of Research Data Services along with my colleague Wei. And if you ever have questions about using data or anything like that, go ahead and email us at data@library.columbia.edu. I'm pretty sure you all are new, so tell me about a little bit about what is bringing you to Polars specifically, or do you have familiarity with data engineering in general or something along those lines?
Yeah.
Sure. Yeah.
Yeah. Thanks for having me. It's I usually use Pandas. I'm not a professional data scientist. I'm actually an anesthesiologist and trying to do my research with that. So yeah, and I was thinking about Polars because it should be faster than Pandas.
Yes.
And we are working with it increases in size like everywhere. So we have sometimes text files, most of the time numbers, just digits. Sometimes it's EG. So yeah, specifically I'm interested in, as I have to handle a huge CSV file, which contains a lot of text actually, but as a CSV with different columns, and I have to find a way to go through it, structure it, and find patterns in it, actually string patterns like keywords or something like that. So and strings usually more or slower than numbers, so I thought maybe Polars might be a way to go.
Yeah, we'll definitely talk about that, because there are certain things that Polars is definitely, or they say is much faster, and the data set that we're going to be using today certainly feels faster than using Pandas. How about yourself?
I have no real experience in coding whatsoever.
Okay, all right, great.
I don't even know what Polars is.
All right, that's perfectly fine. So, well, Polars is in the context of today's workshop, I imagine Polars as the software library that you use in Python when you've already extracted your data from somewhere, and you are preparing it, you're transforming it to then load it somewhere else for analysis. So often the data will come from a database or a bunch of different data sources, and then you need to do the transformation to put the data into a shape that works for whatever is waiting downstream, which could be a data scientist or an analysis team of some sort. So this is how at least I understand data engineering to work, is you prepare the data in a way that makes it more legible to the people who are doing the analysis. You aren't necessarily doing the analysis. And the reason why you would want to use Polars instead of Pandas. So Pandas is the sort of the default in Python for doing this kind of data transformation, for handling dates or working with strings and changing text around or something. And in this way, it has a friend in dplyr in R, which is also a kind of data transformation library, and similar libraries exist in other programming languages. Last semester we worked a bunch with Arquero, which is a JavaScript version of this kind of thing. So Polars is very new from what I understand. Pandas has been around, it feels like forever. I have a hard time thinking of when I have been doing these kinds of data coding notebooks in Jupyter without using Pandas, but I don't know exactly when it started. So Polars instead has a couple things going for it that are immediately obvious. So it's written from the ground up in Rust. So it, as a result, is written at a lower level language. As we say in the business, it's closer to the metal. So it's a faster, it just inherently works faster. So Pandas is an interpreted language. Python is an interpreted language. Oftentimes libraries in Python will be compiled down to C so that they run faster, and they do things like that to make them work faster. But writing it from the ground up in Rust, people love Rust these days. It's very popular, and so that is part of why it can run quicker. Being close to the machine, it is, so like I said, it's much quicker. They have benchmarks where they show that it is just miles ahead of Pandas and is even faster than PySpark and Dask. So, which is particularly intriguing because PySpark and Dask are designed for distributed environments. When you have a bunch of data sitting on many, many, many computers, and you have all the computers working together to do things. Polars tries to give you that kind of speed on your own machine by parallelizing, by doing all kinds of clever little things to make it run more quickly. One of the things it does is it does query optimization. So I won't be showing that this time, but maybe at the next workshop I'll show some of that query optimization. What that basically means is, and if you're coming from a Spark background, this will be pretty familiar, is you tell the computer everything that you want it to do and then do it, as opposed to telling it to go step by step. Do this, wait, do this, wait. So when you tell the computer to do everything at once, the Polars is able to look at what's being done and find moments of optimization. So for example, it may be the case that you are going to filter your data at some point and only take in 1/3 of the data. So it will start with that filter, so it doesn't even have to read in all the data at once. So even if the filter is down the road a little bit, it will look at the query and optimize it so that as little data is worked on as is necessary, again, to make things faster and faster and faster. This is something I think Pandas doesn't have at all. Pandas is still very useful, and I still use it. And one of the main reasons, so this goes to your point about the larger data sets, et cetera. The one thing that Pandas is really good for, and I had this intuition, and then I asked DeepSeek, I'm like, is this intuition right? And they say, yes, this is a perfectly fine intuition. So who knows if it's actually right or not, or if AI is lying to me. But the intuition was that Pandas, because of the way it saves the data, is better if you're trying to do something that's iterative at the row level. So it's moving through the data down this way. So I was doing something where I needed to do transformations across many different columns on one row using different values, et cetera, et cetera. And that works fine, but that feels a little wrong in Polars. And the reason it feels a little wrong, it's a little uncomfortable, is because another reason Polars is super fast that I don't have written down here is because it uses the arrow file format internally, or something like that. The arrow file format is a column-based data format, which means that everything, typically, if you have tabular data, the data will be saved in a row format where every row is chunked together. And this makes perfect sense if you have like a log or your emails or something where one comes in at a time. And so in a database, your bank transactions, much of what you do in the real world makes perfect sense to use row-based logging for it because it's one by one by one. However, when you want to do analysis, the data is often fixed or frozen. So what you want to do is have it be saved by column, because ultimately, typically, you're going to be doing columnar operations. You're going to be finding the average of an entire column of data. You're going to be finding the standard deviation, the median, whatever, or transforming an entire column at once, converting from dollars to euro or something. And as a result, you want the computer to be able to do all those little column adjustments quickly. And the way it does that is because they are, this is how I say it to myself in my head, they're close to each other on the disk. So the disk, I'm used to old time hardware spinning platter disks where the arm has to move around. So the idea is the arm doesn't have to move around as it goes through the different columns, as opposed to when it's saved by row, it has to jump from place and place and place in the disk because everything isn't stored in the same place. So this arrow is a way of transmitting data over in memory that is exceptionally fast, they say. I haven't tested it, but everyone says that. Arrow has a sibling file format called Parquet, which is a way of transmitting data over the internet. So Parquet is a kind of CSV on steroids. It is, are you familiar with Parquet files?
No, but it's interesting.
Yeah. So I have been for a very, very long time a huge, huge, huge proponent of CSV. I am all about making files human readable, and CSV, comma separated values, is just a regular text file. You can open it in nearly anything in the world, but there are a few problems. The first is that because it's saved as a plain text file, it takes up way more space than it should. Parquet files are saved as binary file format. So you can't just open it in anything. You have to open it in something that can read a Parquet file format. Luckily, Pandas can do that. Polars can do that. I want to say nearly any contemporary data wrangling library or application will be able to do that.
Is it like pickle files?
It's close. So Pickle is just an abstract format that lets you save any kind of Python object for Python purposes. So it's close in the sense that it allows for you to save plus minus anything, but Pickle is much, much more general and Python specific. Parquet is not Python specific. It's created by Apache and it's related to the arrow format. But it is binary in the way a Pickle file is binary. The other things that Parquet files do is they are also column. They're saved by column, so that you get those speed benefits. And then also, they, very valuably for me, have typing on the columns. So what does that mean? A CSV, when you read a CSV into something, it has to guess what file format every column is in. And you can have a CSV that actually has different kinds of, and you'll see this I see this all the time when people come and bring in a spreadsheet. They'll bring in a spreadsheet where in the same column there are dates, there are numbers, there's text, because it's, whatever. You can't do that in Parquet. A column is one thing. It's either integers, floats, dates, strings, other sorts of things. And that gives additional speed benefits. Because if the computer knows ahead of time what to expect, it can optimize for that sort of thing. So in Pandas, if you try to do this with a CSV, it just dumps everything to the most generic file format, or the most generic type, which is object, and you get no benefits. And it has to convert every object into an integer to do math on it and things like that. Whereas with a Parquet file, boom, integers right away. So we'll see this in a second. So far so good? Any questions?
What's the difference between a CSV file and an Excel file?
So an Excel file, so that's a great question. So the Excel file is, there are a couple very obvious differences. One is that an Excel file is actually a workbook as opposed to a single sheet. So 20 years ago, if you opened up an Excel file, it was just a single sheet. But then they introduced the workbook idea where you could have multiple sheets. A CSV is only ever one sheet. It's one table. And the same goes for a Parquet file. A Parquet file is only ever one table. So it's only one sheet of an Excel file. Excel files are binary as opposed to plain text. But it's funny because they're only like a little bit binary in the sense that the XLSX file format is actually a compressed XML document, so you can actually unzip it. This is in the weeds, but you can unzip it and you get an XML document, and then effectively the difference between CSV and XML is basically one of taste. You know, whichever one you like more. Yeah.
I think the key difference for me is you can open CSV in Excel, but Excel can only be opened in Excel, which is a paid software.
Yeah.
So that's why people like CSV, because you can use your plain text editor to open it. And if it's in a nice shape, you can still read your data without pay Microsoft. But
Yeah.
you cannot do data analysis for sure using the text editor.
Well, Pandas will read Excel files, so there's a certain amount of openness, and this Microsoft has been, to be fair, pretty good about this in the last decade or so. When they brought out the XLSX file format, it has been more standardized, etc. And also in an Excel file format, you can do things like equals and then write in a formula or something. You can't. CSV is just a fixed static data by itself. You can't do all the kinds of things.
But when we talk about faster, right, if you do all the formats in Excel, it
Yeah.
will be very huge size. Then
Correct.
that will slow down your data speed.
Right.
But if it saves in that comma separated format, then
Or in
Or in
Parquet
Parquet,
or
yeah.
something. Yeah, and also Excel has, because it's an XML format, it's a much richer format. So things like colors, fonts, all that sort of stuff that you can do in Excel, forget it. You can't, like a CSV is just, it looks like a printout from the 50s. You know, that's,
and those things will cause your storage and will slow down your
Yeah.
speed. So
Yeah, like
that's
the
not good for data.
The
analysis.
colors and all of that.
Yeah.
yeah, the colors and all that sort of stuff. I mean, it is, by the time the colors would slow you down, you're probably actually not using Excel anymore anyway, because the data is so large that just that opening it, and even if it's a CSV, just opening it in Excel takes time.
Like Excel can open CSV files.
Oh yeah. I don't know if Excel
But
can open.
you need to save it as an Excel file to do those filter,
Okay.
color,
Yeah.
highlight. And once you use formula, once you use filter, once you use color, using any Excel functions, it will be very big.
But something like Jupyter Notebook could open Excel files.
So Pandas or Polars inside a Jupyter Notebook would open an Excel
But
file.
I think the key point is if that Excel cannot be opened in Excel because it's very huge.
Yes.
Do you think Python can still use very fast speed to open such?
I would. I mean, well, the short version of the answer is, and this is the data engineering version of the question, which is whatever format it's in, it's not going to stay in that format for long, because when you read it into your Jupyter Notebook, it's going, in the case of Polars, so in the case of Pandas, it converts it into the Pandas data frame, which is based, I think, on NumPy arrays, et cetera, et cetera. So it converts it into its own thing anyway. And then at the end, you can say, save this as an Excel file.
Okay.
And, or save this as a Parquet file, or save this as a CSV. In Polars, it will do the same thing, except it will convert it to this arrow format that I mentioned. So it'll read Excel, CSV, whatever, but when you're actually working on it, it's effectively an arrow file. But you can save it as whatever. Like that's up to you. Okay, so let's get into this. So you have to, I have to sign in again. Give me a second. This is 2 data clubs in a row where I forgot to sign in ahead of time. That's okay. Dun, dun, dun. Okay. Right, so I am now signed into Google Colab. You should be too. You should see your picture up in the top right corner here if you have a picture or it says Google account. That's great. My email is visible to everybody. And then I go down here to the first line of code and either press play. If you're not familiar with the Google Colab environment, it's Jupyter Notebooks, except in this little environment, that means we don't have to spend half an hour getting everyone's Python installation to work correctly, which is what we used to have to do. So instead, you just press play, and it'll say this notebook was not authored by Google. We say that's fine. There's nothing weird going on here. And then it will connect to the runtime, and this takes a little bit. And it connects, and we get the green check, which means we're in shape. Now, the Polar syntax, there are 2 basic structures to think about, and those are expressions and contexts. An expression is an expression of some kind of data transformation. And that can be any number of things. It can be casting from one type to another. And here I have one that takes a column called tip amount and divides it by a column called fair amount and saves it as this thing called tip percent. So if I press play, we get this sort of thing here. Now, what's notable about this, to me at least, this is not a function. This might feel like a lambda or an anonymous function that you just run inside of something else. It's not that. It's something a little bit different. It's what it is. It's just an expression. And you can tell that this has it's referring to things that, for a data set that doesn't even exist yet. We haven't loaded any data yet, but we can already define what we mean when we want to get the tip percentage. Is going to be the tip amount divided by the fair amount. And we know ahead of time that there's going to be a column called tip amount and a column called fair amount. But you can do this to make to break apart your code, to separate out your, I don't know if this is appropriate usage, but to sort of separate out your concerns and make the code more granular and modular and in some ways more readable. You'll see that in a second. Now let's read in the data. So the data is from the New York Transportation, what is TLC? Taxi and Limousine Commission. So they have data on taxis going back to 2009. I use this data set all the time because I find it amusing. And they don't have 2025 data yet. I think there's typically like a 6-month lag, but they have they have December already, so that's not 6 months ago. So there's a little bit of a lag, but they have December. And you can see they make their files available as Parquet. Why? Because these files are enormous. And if they used to be available as CSVs like many years ago, and they were just even bigger. And now so yellow taxi trips, yellow cabs are cabs that are allowed to pick people up in Manhattan. Green taxis are taxis that are not allowed to pick up people in Manhattan and typically serve the outer boroughs. For-hire vehicle trip records are like limos, and high volume for-hire vehicle trip records is basically Lyft and Uber, and mostly Uber. So you can get all these kinds of data for every month. Don't get too excited because the data has problems. But we get this file. I don't know how big it is. I don't know if it's gigabytes in size, but it is large. But we press play and boom, it's done. So I don't know how much that is just that the internet is fast, and how much it is that reading it into memory is reasonably fast. But if I press df shape, we see that there are 3.6 million rows. So this is a data frame with 19 columns, and that's million, right? Yes, 3.7 million rows that loaded in a snap. And we can look here in the RAM thing in the Google Colab and look at the RAM being used, and it's barely noticeable here. So again, I don't know how much of that is the Parquet, how much of that is Polars. I just remember it taking a little bit longer than that to load when using Pandas. So these are just some basic, very, very initial commands that show you information about the data. So we can do df columns to show the columns. I'm pretty familiar with this data, so I can tell you what most of these columns mean. The PU location ID and DO location ID don't refer to precisely where the pickup and drop-off were, but they refer to a zone. Manhattan is divided into something like 150 different zones, so you can geospatialize the information a little bit, but not down to like this taxi got flagged at the corner of Tiemann and Broadway. We have pickup and drop-off time, passenger count, distance, etc., and then different things regarding the price, fare amount, tip amount, tolls amount, congestion surcharge, etc. If we do df head, we get by default the top 5, just the top 5 rows of the data frame. And I ask this as a general question. Again, I don't know how super familiar you are with Pandas, but is there something different from this than from Pandas? The Pandas head command.
It has 2 headlines.
Vendor ID and this I32. Yeah.
That's a label. I mean, the I32, those are data labels.
Yes, it's the type. Because we read in the Parquet file, which is typed,
Yeah.
/ polars also inferred types. So we have I32, 32-bit integer, date time, millisecond, which means that natively, quote unquote, this date and time are encoded as milliseconds since the epoch, since January 1st, 1970. But it immediately parsed them into this date time format, I64, 64-bit integer, floating 64, then we have str, string, and so on. And that's why we have the second row under the head, because it's telling us the type, which is just a very small thing, but automatically makes me feel like this is a more serious thing. And then also I'm not 100% sure on this, but I think Pandas won't show you all the columns, whereas this will. So we can see all the columns. There's another command, I didn't put it in here, but you can do df glimpse. Nope. I thought it was glimpse. Give me 1 second before I ask Google. It's a word like glimpse, but not
This
peak.
is for sure in R, but I don't know what's in Python.
Yeah. Yeah, give me a second. I thought it was glimpse. Glimpse, maybe I was misspelling it. df glimpse. Weird.
Do you need to use the print?
Well, Yeah, I mean, let's try it that way. Well, this return as string true, but no, but it was complaining that there was no, yeah, let's just do this. I don't want to, oh, I was spelling it wrong. Glimpse, there we go. Press play. So if you have particularly wide data frames, it will transpose it and it will show you each column as a row with some initial values. This is a little bit like, I feel like I've seen this in R. So this is helpful if you have many columns, because this is in many ways more helpful than just scrolling like this. And is actually a little bit more economical because it's showing 10 or so files. Yes?
So the vendor ID is the company?
It is not interesting because I think there's one of two types of fare boxes. It's something like that. Like it's one of two. So the only two values.
I only say 2211. So
Yeah, I think there are only two values. Yeah, so it's not. I thought it would be fascinating to have like the medallion number or something, so you could track a specific cab. But no, it's just, I think it's related to the actual taximeter, yeah, that they have. Okay, so and then we can do the usual value counts, where we can do, I skipped a little thing here. So let's go over this command in a little bit of detail. So it starts with select. This is a expression that's familiar if you use dplyr or if you use a database, if you use SQL. What you're doing with select is you're saying, give me a certain number of columns, or give me a transformed new set of columns. So what we're doing here is we're saying, select a column called passengers, which doesn't exist. So it's going to create a new column called passengers, and it's going to set the value of passengers to plcall, which is the Polars column passenger count. So it's saying show the passenger count column from the data frame, and then on that column run value counts sort equals true. So value counts is show me all of the unique values that are in that column and count up how many of them there are. So in English, what's happening here is it says, show me how many rides were taken with n number of passengers. So if we run this, we get it sorted. The most rides were with one passenger, not particularly surprising, which was 2.5 million. How many total? There was 3.6 million, yeah. So 2.5 million of 3.6 million taxi trips are with one passenger. Number 2 is next, then null is third, which is a little bit disappointing. That's when I said don't get too excited about this data because it has issues. So why are 300,000, 326,000 taxi rides, why do they have null in the passenger count? I don't know. And then so on and so on and so on, and then we get up to 9 riders, of which there were 2 trips. I don't even know what kind of cab has room for 9 people. I don't know,
How can they count those numbers?
I don't know how this sort of. Oh, the passenger, I think you encode it because that adjusts how much it costs, or maybe I'm confusing it with Europe.
That's coded by the driver?
Yeah, I think the driver goes tap tap if there's 2 people.
Oh, I don't know that.
Yeah.
Wouldn't the null data be somebody calls for a cab?
Yeah.
The time it takes for the cab to arrive to your destination?
Is that going to be encoded in this?
Could that be the null?
Oh, could that be why it's null? In the sense that it's a cab that's riding without any passengers? It could be because 0 is not here. Maybe this is 326,000 burritos, that people ordered on DoorDash, and a cab went and got the burrito. I mean, I honestly don't know, but this is a very large number.
This is the yellow cab.
Yeah, this is yellow cab,
like
not doing DoorDash, yeah. But still, like this is 326,000, so this is 10%.
The question if this is empty, so null. So in German, null is 0.
Right.
So
But it's
not the number 0.
it's not the number 0. Yes, this is a special data type that I'm going to talk about in the next workshop, because there's something Polars does that's rather clever about how it handles missing data that Pandas doesn't do, in the sense that it's stricter, so it's much more intentional. But yes,
This
these
is
are
not missing.
not
This is-
zeros.
This is not 0 and not missing.
Okay.
Because zero fits in the data type of integer 32. So like it didn't convert it.
But
This
what
is
that
empty.
in between, like 4 and 5?
Maybe there's a 0 there. I just thought it was showing just the top 5 and the bottom 5, but it ends up being that there are only 10 values anyway. Well, let's see if there are any that are 0. Just really quickly, let's do df filter. Yeah, sure. AI is telling us what to do. Let's just do this.
Oh, you do have 0.
Okay. Oh, so maybe 0 is this middle area here. So there's 30,397, passenger count 0. So maybe these are the burritos, where the passenger count is 0. So what did I say? 30,000? Yeah, so it's right in here.
So then none were definitely no data.
Yeah, it's something different.
So that means the driver forgot to count how many people in that ride.
Yeah, I honestly have no idea, but it's 10% of all rides. That's wild. And then you can see that it returns data in this struct format, which is kind of like a tuple or a set maybe, I don't know exactly. But if you do the unnest method, then it will replace the single struct with 2 columns. So this is integer 64, U32 is probably unsigned integer 32, because the count won't be negative. The value count won't be negative. The passenger count, who knows? But I'm pretty sure there aren't any negative ones.
Is it nesting, and is it possible to do multi-dimensional things?
So-
is it a good way to do so? If this might be a big third dimension of data?
Right, so that's a great question. This supports this, because among the supported data types, so integer blah blah blah, there are 2 more, which are list and array. The differences are, so a list is not exactly like a Python list, because a Python list can be heterogeneous. A Python list can have strings or numbers or anything you want. A list in Polars has to be homogeneous. It has to be all integers or all strings or something like that. But it is brackets, and you can do list whatever stuff on it. An array is the same thing, except not only is it homogeneous, but it has a fixed length across the entire column. So it just amps up the speed, because when you know how fast it is, you can, or when you know, data structures, so when you assign an array with a fixed length in the beginning, the indexing is much easier, and you can find the data much more quickly. So that sort of stuff is built in. Whether that expands to actually using a Polars data frame to do actual multidimensional stuff, I am a little, I would say that something like Xarray is perhaps a better solution for something like that. But it is available, and I haven't used Polars a bunch, but I've already done that. Like I've used lists inside Polars. Okay, so we did this little filter, and then the context should be, we already saw select. There are 3 others: with columns, filter, and group by. With columns is I think there's a PySpark command that's also called with columns. Select will let you create new columns like we did. So what we did here with the passenger count, let's nest it back up. You can see that it called the new column passengers, which is what I have here, passengers, passengers. So it took passenger count and got the value counts and then did the struct. So in select, you can name new columns. You can also use the .alias method to rename a column. But you only ever get back columns that are mentioned in the select command. So you have to do select blob A, B, C, D to get those columns. With columns works the same way, except it returns the entire data set along with the new columns that you made. So if I change this to with columns, I think this will work. With columns, oh, it won't work. It obviously won't work because it's doing the value count. So let's just add 200 to every passenger count. And then if I do this, this should work. So I get the entire data frame back, and then all the way at the end, I have this passengers thing that has added 200 to every value. So the difference between select and with columns is that with columns, you get the whole thing back. And that's why it broke, because originally this command gave back just something that was 11 long, which were the value counts. OK. So here's where things got tricky. So let's have a look at this. Let's have a look at some of this stuff. So select lets you choose, but also aggregate certain columns. So I created this trip duration column, which is the drop-off time minus the pickup time. So easy peasy, time math, don't even have to think about it. And you can see that the type is duration. So natively, this column is milliseconds that are understood not as time since the epoch, but just a duration of time. And then just the distance is just distance equals trip distance. So it's just renaming the column. And it gives the top 5. Then I can also ask it to describe these things. So I get statistics about this. So I get no nulls on either trip duration or on distance. The counts are the same. You can see that they're presented in slightly different formats. I'm not 100% sure why that is. Then oddly, I'm not sure why the trip duration would have a null standard deviation. I thought about it for about 5 minutes, and then my head started to hurt, and then I'm giving you a couple seconds to try and guess why there would be no standard deviation for trip duration. But we know that the standard deviation for distance, I can't remember if this, I think this is in, what's the mean? 5.08, probably kilometers. Does that sound like an average taxi distance? 5 kilometers, 5 miles?
In New York, yeah.
Yeah. But I don't know why the standard deviation would be 472. Oh,
because of the maximum is like very huge.
Yes,
so standard
that's
deviation-
right.
The same for your non-standard deviation. You have a negative 1 day and 4 days. Those are crazy numbers.
Yes.
To your
Right, right. So
Did it
this,
go backwards?
what's that?
Did it drive backwards?
Yeah, so these are, so the negativeness of the negativeness of the trip duration, yes, perhaps it ran backwards. It's a little bit, it's somehow a little bit telling to me that it's minus 1 day and 23 hours. So like, cause it's so close to being 2 days, but I'm not sure. But that shouldn't change the standard deviation. Like, it's okay to have.
This is a trip thing, right? Like
Yeah.
per trip. So that means, so we don't talk about the negative, and the maximum means that trip costs 4 days. So that's like totally out of the city.
Yeah, well, who knows? I mean, it could be just the system, like, this data has
Raw
weird,
data, so it's very
you'll see this data has many bizarre things. Among them, a taxi ride that lasted 4 days. and that drove 328,000 kilometers. That's probably going around the world a couple times. So who knows how this stuff is measured, but that explains the enormous standard deviation. The mean, thank you. So maybe 75% are 3 or lower, so maybe it's miles, not kilometers. Anyway, then we do tip percentage. And we see, so I do two things here. So I invoke the tip percent that we defined way back up at the top, and then have mean tip percent equals tip percent dot mean. So we can see that it's calculating a mean tip for the first couple of values here. So this $20 fare, or this 20-mile or whatever fare, didn't tip at all, apparently. But the mean is not a number. So, okay, why is the mean not a number? I mean, I know the answer, but you have to sit through this with me because I had to suffer as well. I'm sorry.
I don't understand why you count the mean of the percent.
So just to see what, all right, so the question would be, how much do people tip on average as a percentage of the fare?
So that means you want to have the mean for the whole column.
Yes, yes, so
And
this
in
is,
that way, you should not create a second column.
well, ish, because this is a little bit of a funny thing, because we are, one version of us, or me, expects, like, wouldn't want just the same value over and over and over again in a column. On the other hand, what difference does it make? You know, it's not, I'm not adding appreciably probably to the memory image or anything like that. And you can do, so it is just the same thing over and over again. So it's the reason it's nan in everyone is because it's getting nan, not a number, for the same calculation over and over and over again. So these should all be the same, and they shouldn't be not a number. So why is it not a number? Well, then what did I do here? What did I do different here? Nothing. I think this is the same. This is the same thing. So then I say, okay, well, let me see the description of tip percentage. Oh, the maximum tip percentage is infinity. That's not likely. So if it's saying infinity, what's very likely the problem? Any guess? If the maximum tip percentage is infinity, then, and the tip percentage is the tip amount over the fare amount, then what does that mean? How do you get infinity? You divide by 0.
Yeah.
So that means that there's at least one fare amount that is 0, and it gets us infinity, and once we have infinity in the calculations, forget it. We get nan for the mean and the standard deviation. And now you can start seeing some of the completely bizarre things here. The minimum tip percentage is negative 22%. How on earth do you tip negative 22%? The cabbie is giving you money.
You know, there was a reel about it, where you, if you tip and then you choose custom, and then you, what was it? You type it in.
Like right minus in the custom.
Yeah, something. I don't know if the minus was possible. It was something,
Yeah.
something
You can
looking
have
smart.
0, right?
Yeah, something
Yeah.
like that. Yeah. So.
Oh, yeah, or
Oh, no, you say you count. You can choose. I mean, in some places you can choose either the tip amount or you can choose a total amount.
mhm.
And if, let's say, the trip was $20, but you type in total amount, including tip $15, then you get a minus.
Yeah,
I
yeah.
don't know
So
if this is really, I never tried it.
right.
But this was what I mentioned.
Yeah, so this could be a function of that or just busted data, but one way or another, infinity is certainly or almost certainly wrong. So if we look at the fare amounts, we can see that these are all over the place. So none is null. The minimum fare amount is negative $975. That does not strike me as at all realistic. The maximum is $3,000, which maybe. I mean, I've done this with, this is the first time I'm doing this with the December 2024 data, whenever I do this, there's always at least one trip that is in the thousands of dollars, and who knows how that happens, but whatever.
But the 75% is $23.
Yeah, and
So
then
that's pretty low. Like in my opinion, if you have a cab in Manhattan,
yeah,
it's the 50.
well, it's yeah. So I mean, the mean is $19, and if the mean distance is in the vicinity of like 3 miles, I mean that sounds about right. I think. I don't know. I mean the aggregate feels closest to right. I mean, just sitting down in a cab gets you to about $9. It feels like. I don't know. So we have zeros. We have 2,000 zeros. So one solution to get these tip percentages is to just add 1/10 of a cent to every fare amount. So then we no longer have the zero fare amounts. And that works fine. I mean, we get this little extra one, but also this is marginal, like who cares? But then instead we can get a little bit fancier here. So we can do df with columns. So then when we use with columns, we get the entire data frame back. So this is df with columns, change fare amount to add this 1/10 of a cent, and then select fare amount, calculate the tip percentage, et cetera, et cetera, et cetera. And now we finally get a usable mean tip percent, which is 23%. So people tend to tip on average 23%. In the past, when I've looked at this, you can see in the distribution that there's a mix of people who press the percent button and people who press the dollar button on the thing. Because I think you can do one or the other, like tip a specific dollar amount or tip a percentage. And it's very stepped because it's not a continuous variable, because you can't tip in between pennies. So in any case, this fixes the problem at the cost of inflating every single fare by 1/10 of a cent. This is just other stuff. And then we can filter out, which works exactly like you might expect, filter out all the rides that don't have zero for the fare amount. So that's this, fare amount not equal to zero. And then do all this sort of stuff. And we get, again, a functioning answer, although now it's a completely different number. It's 19%, 19.3%. So filtering out how many was it? Filtering out the 2,000 rides that had a fare amount of zero was enough, but that makes sense because whatever they're tipping is going to be divided by 0.001, so that will inflate it. And then this is the same thing again. Oh, no, these are all things I already did. And then the last solution is to use this expression when. So we do fare amount equals PL when the fare amount is equal to zero, then add a bit of a penny. Otherwise, it's just the fare amount by itself. And this gets us back to 23%. And this is about the closest that we can get to the reliable-ish data. The fare amount is 2,000 fares out of 3+ million. So maybe just drop the zeros, et cetera, et cetera. We can also filter by date. I particularly like this. We can look at all the Christmas rides, all the rides on Christmas. And did I sort here? No. So these are just all the rides on Christmas. And we can see when they got picked up separately. So we have the entire date time here, but we separated out just the time. So this is 3 minutes after midnight when the animals are still speaking. And you have, so that's just here. Pickup time is the date time column cast as a time object. So it's turned into 3 minutes after midnight.
Is the tip more at Christmas?
What's that?
Is the tip higher at Christmas?
That's a great question. We, unfortunately, we'll probably not really have time to look into it. But yes, like this. All right, it's not going to take that long.
Yeah, you can add a filter.
Oops. I somehow zoomed in. There we go. So we're filtering by Christmas, select and then we can do tip percent equals tip percent. Oh, and then the mean. Mean tip percent equals tip percent mean. We get nans because there's probably a 0 in there, so let's just quickly do a select fair amount. But we have to do this way. Fair amount. That's not how you spell amount. No, that doesn't look right. Yeah, fine. Plus 0.01. Oh, 0.1. What am I doing wrong? This.
The time thing. You do need to define the daytime, the TPEP. So see that curve thing.
Yeah.
Yeah. Do you need to name it as something, or you can just?
No, it should be fine, but I don't like that it's complaining. So you may be right. So I have.
Because you
There's a
have
comma
something else.
here.
So everything has a new name, but you want to keep this.
Right. I mean, I can just delete that. Oh, maybe it's because it wasn't the first one. So that's one way you can just duplicate the columns, but maybe they have to be the first ones. Okay. Still not a number. Yeah, all right. Unfortunately, go ahead.
You use your last chunk when you calculate the mean tip, but only filter out that day.
Yeah, let's give that a try.
Because this is already there.
Yeah. There we go. Nope,
Oh,
16%.
But it's less.
That's
Yeah.
less. Yes. So
interesting.
now we know. Let's see. What about Christmas Eve?
But that's for the
18%
fair
more.
amount.
So who knows how much this varies? Yes.
No,
What were you going to say?
interesting.
Yeah. This is, even though I'm only showing 5 here, this is calculated across all of the
No,
trips for that day.
I'm thinking about
Yes.
is that because it's the amount equal to 0 section?
Where?
Or you change it to not equal to 0? Fair amount. So this is for all the fair amount equal to 0.
So when the fair amount is 0,
Not
it
equal to-
adds a penny.
Okay.
Or
so
a tenth of a
still
penny.
everything there.
Otherwise, it just
Otherwise,
has
it's
what's
so it's
already
a
there.
whole, so
Yeah.
okay.
Yeah. So it probably the best thing would be to just filter out everything that has 0 for a fair amount. And that would be that would have been faster than all of this. So actually, why not? PL call fair amount is not equal to 0. Do I have a comma here? Yes, I can get rid of that. And then let's see what happens here. There we go. Yeah, so 16% again, with all the zeros deleted. So the however many 0 trips there were, they weren't having a big effect on the mean. But yeah, 16%, not great, not great. What about New Year's Eve?
Because people spend
18%. So
don't have enough money to
New-
pay for the taxi.
New Year's Day is maybe I was living in Lithuania when Lithuania went from their money to the euro, and it happened on January 1st, and it was like the worst New Year's Eve I've ever had, and I just was so mad that I had to take a cab, and I took the cab all the way back to where I was living, which was outside of the city, blah, blah, blah. And I looked at the price, and I was like, is that euro or litas? And the guy was like, it's January 1st, what do you think? And I was like, oh my God. Because it was 4 times more expensive than normal, right, at least.
Oh my God.
No, 10 times more expensive than normal. It would normally be 30 litas, but it was 30 euro. No, that's not right. 30 litas was about, no one cares. 30 litas, 100 litas was 30 euro, so 29 euro. So 30 litas was about 10 euro. So it was, yeah, so 3 times as expensive. One or another, it was money I didn't have, and it's like insult to injury. But, so I understand January 1st not wanting to tip a lot or on New Year's, because you're just like, man. Anyway, so then we have these kinds of, we can do other sorts of little things here. We can do in between dates and times. So these are Christmas Day at between midnight. I meant to do Christmas Eve and Christmas Day right at midnight. So we get these answers in the average trip distance, what the maximum was, the minimum, 0 for some reason. And then this is the last bit I have here, which is just using group by, which is exactly what it sounds like, where you can group by passenger count or whatever kind of other thing. You can do rounding, get the length of how many trips. So we saw this earlier with the value counts, but this is now not relying on the value count thing. The mean trip distance based on passenger count. We can see, in another sort of indication, when the passenger count is null, the mean trip distance is much higher than it is with the other trip distances. So maybe there's a relationship between why we get these nulls in the passenger count. And then doing the same sort of grouping with date information. So we have how many trips were taken on a certain month and day, and this is where we start to see really bizarre things, because this is 2024 December, yet we have a trip taken on December 31st, 2008, and another one taken on January 1st, 2009. And
now I think this is manually input data.
A trip taken on, 3.6 million rows.
Our library has that, the reference login system.
Yeah.
And if you log in now, you will see some people, the whole, this type of data sheet will say 2026, certain date and time, there is a reference or consultation happened, how long time. And I think then now I doubt this.
Yeah.
This is not like purely machine data.
Yeah, November 30th, so right outside the window, a day before, 26 trips. And then trips in the future, like March 23rd of this year, which hasn't yet happened. So I did do a little research project with the taxi data. I mean, ultimately, you sort of just wash out all this weirdness because you have 3.6 million rows. Like, it's fine. But they are amusing little wrinkles. This single taxi ride from the future of today. And then I closed off with just this sort of, are we low-key EDAing here? Like, is this a very low-key kind of exploratory data analysis? And yes, it's fidgeting with these different kinds of ways of making these expressions to get things like means and value counts and whatever. And this is all stuff that can be done in Pandas with Pandas's syntax. I'm starting to like this syntax more with the specific select and with columns, as opposed to Pandas's slightly confusing expressions that you put inside brackets, etc. And it's whip fast, and I like that too. As for how it works on doing string testing, like testing against strings, like what you were saying, like with textual data, I'm not sure if I'm not sure what the fastest way to do that is. When I've had to do that in the past, the actual file format didn't matter because I was just iterating row by row to feed the text that was in the data into a model to do sentiment analysis. But if you are doing a search for a particular word or something in your data set, what I typically do for that is I tokenize in stem to reduce the variability of the vocabulary, drop stop words if where necessary, to also reduce how much textual data there is that we consider probably not important, like the word the, and then integer encode. So that has a slight savings boost, not a huge, a couple percentage points of a savings boost, but will be much, much faster for information retrieval. So do you know what I mean by integer encoding?
Not exactly. I have a rough assumption, but I see I have to look into that a little bit deeper,
Yeah.
how to go through it.
Yeah, so
It's like indexing the words, or?
yes, exactly. So what you do is you build a vocabulary
Yeah.
based on the entire vocabulary of the corpus.
Yeah.
And you can do this with Python's default dict like very, very quickly. And it, I just did this last week, and it just goes bing, 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 and you get this huge data dictionary that where the key is the stem, and then there's an index associated with it, or it's the other. I mean, it doesn't matter. And then what you do is you convert your list of stems that represent the text. You convert that from little strings to integers, and then that's just bing, bing, bing. It's much, much faster because it just is. And you can start, like, this is a necessary pre-processing step for a lot of machine learning stuff too, because machine learning doesn't know what a string is. It needs to do math on stuff. So yeah, so any kind of pre-training for a large language model or something along those lines, whether you are doing that intentionally by using, I think scikit-learn has like an input encoder or an integer encoder, or if it's just being done in the background with whatever library you're using, that's going to happen. But that's not inherent to the file format here. I don't think that polars would have a particularly fast seek in that sense. Yeah, and that's it. That's all I've got. I hope this was kind of illuminating a lot of stuff. I wasn't expecting to talk about my taxi ride, but
What is part 2 about?
So part 2, I'm going to talk about a little bit about how Polars handles missing data, which is different from how Pandas does. Pandas is a little bit, I think, loosey-goosey in comparison to Polars. I'm going to look more into the different kinds of expressions. Like we handled most of the contexts. Oh, there's one of the contexts that I think I grouped by dynamic. So I just sort of yada yada this one. So this creates you sort by the pickup date time, and then you do dynamic grouping by the date time iterating every one day. So this is a way of saying that, group by the specific day. So that's how come we end up with 2008, 12/31, 2009, 01, 01, this list. So there are 39 different days in the data set.
Oh, okay.
So it's mostly right.
Can you do
But
by
why
week?
is it only 39 days?
Well,
Because
it
those
shouldn't
raw
even be
data-
39 days. It should be 31 because it should just
Yeah.
be December.
Those raw
It's
data.
only December. I
Yeah,
thought it would
yeah,
be
yeah.
the whole year.
No,
Okay.
no, 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 no. This
okay,
is
yeah,
just
that makes sense.
yeah.
It's these other dates
Yeah.
in the future. Okay.
So
I
it's
see,
the
yeah.
31 days of December
Yeah.
plus 8 weird ones.
Can you change it to 1W? So that's a week.
Yeah, sure. I mean, well, I think. Yeah, these look like weeks. December 2nd, December 9th, December 16th.
Interesting.
This is pretty cool.
Yeah. So the dynamic is the polars only, not from Panda.
I
Or
would
from daytime. Because you import two, one polar, one daytime.
right. So the date time import we use like, or actually not even here, but I used it up here just to define a date. So I could possibly have done this differently to ask for New Year's Eve, but this is how they do it in the manual, so that's how I did it. But this is
So dynamic is from polar.
this is from polars, yeah. So it's so maybe I'll look into this a little bit more because it's a provocative way of grouping dynamically. So by a time
Maybe
increment
they
or by
also
some
do
other
by
kind of
quarter or something.
well, or by every 100
Bi-weekly.
transactions or every not even thinking in terms of date time, but grouping
I think
dynamically
about
by other
dynamic
things.
Means time, but you mean dynamic could be other things.
Yes, it's creating the groups dynamically. So it doesn't know ahead of time. Sorry, it could be just date time. But in my head, what it sounds like to me is that it doesn't know ahead of time what the actual groups are. Like if you say group by color, then it looks at the color column and it pulls out the 8 different categorical variables for different colors and then groups by them. But here it doesn't know
for
ahead
example,
of time.
This is not daytime, this is race or ethnicity, then it's every equal to some black, white, whatever thing.
Yeah, so well, I mean, the group by would be like for a categorical variable like that, but this is doing it dynamically because it doesn't know ahead of time how many days there are, so it doesn't know how to chunk it into specific days.
Right.
So-
So the average is your chunk. Every equal to is the units you
Yes.
want to do the dynamic.
Yeah, for date time. I don't know how it would work with other things, but yeah. So maybe I'll look into that. And there are more expressions, and then they recommend using polars with, just in the documentation, they recommend using it with Altair instead of Matplotlib. Altair is built on Vegas,
How
which
to pronounce it?
Altair.
Isn't that a software company?
Altair is an old computer company, I want to
Yeah,
say.
I think they're doing something like MATLAB or something like that.
So that's a virtualization thing?
Yeah, okay, so they still exist. Multinational information, HyperWorks, etc.
Yeah, I think my brother-in-law is working there.
Well, yeah, I mean, I just remember something like an Altair computer from the 70s. There we go. Yeah.
They
That,
have a GitHub for the Python library. If you go back to your Google, you will find that GitHub.
yeah. So this is what I was thinking of, was this old computer that was based on the Intel 8080. And then Altair Vegas, or Vega, is a visualization library that I don't know anything about, but I'll look into also potentially. So this is declarative, so it's a little bit more like ggplot probably.
This is the consistent API thing, so it's way much cooler than ggplot. I think it's an API-based
Yeah.
gallery.
What I think what they're suggesting here is that you basically write it the same way whether you're using Altair on Python or Vega/Vega Lite in JavaScript. But I have learned neither, so maybe there will be a little bit of that in the next one too. That's it.
Interesting. One question a little off topic. Have we
Yes.
discussed about these time things? That's